Pythagoras, and we're doing the relationships unit, and we're looking at Pythagoras in 3 dimensions. Your starter questions and your solutions. So your learning intention is I can use Pythagoras' theorem in 3D problems. You'll be successful if you can read the question properly, if you remember the formula, and you can calculate accurately. Now, for this, it's a wee bit of problem solving for these types of questions here, because quite often it's not obvious what you actually have to do. So our core skills that we're going to be using today, we're using our numeracy skills, obviously, thinking skills, but also employability skills, because we're going to be using an initiative for quite a lot of what we're having to do. Now, a lot of you will have seen this already when we did level 4 and we looked at Pythagoras in 3 dimensions, so hopefully this isn't too much of a shocker for you. Now, here's your example. Probably most of you are going to find it difficult to draw your cuboid. Okay, so remember, I'm just going to do a wee quick tutorial for that. If you draw your rectangle, and then from the 3 corners, do your diagonal lines and then join them up. Okay, obviously I've not got a ruler there, but it's hard enough trying to draw on my iPad without worrying about that. But you should have rulers when you're doing yours. Okay, so we're asked to find the length of AB, which, if you can imagine, is going straight through the space inside the rectangle. Now, for us to be able to do that, we need to know some lengths. I'm going to have to know what this length here is, and I do because the height of the rectangle is 3. And the kind of shape that I'm going to look for here is a triangle. I need to be able to have a triangle so that I can actually work out some stuff. So that length AB is actually the hypotenuse of a right angled triangle. Hopefully you can visualise that. My problem here now, though, is that I know what the this length here is, so up and down length, but I do not know what that bottom length is. So I need to be able to work that out. Do I have the information to work that out? Well, I do, because if we have a look at the bottom face of our rectangle, I have this line here, and I know information about it, and I have this line here, and I know information about that. And what I can do basically is do Pythagoras twice. So if I do Pythagoras twice, the first time I'm going to be working out this length here, that hypotenuse, which just so happens to be the bottom length of the triangle we need to use to work out the question, the answer to the question. So what we're doing is we're using Pythagoras twice. Hopefully it has a bit more sense when you look here. So we're going to do the blue triangle first of all. Now what I'm going to do is I'm not going to square root anything. I'm going to keep everything as nice whole numbers, and you'll see why in a wee second. So the blue one, I want to find the hypotenuse, so I'm adding. Big side you add, small side you subtract, but it's big side that we're using, so I'm going to do 2 squared plus 4 squared. And when I do 2 squared plus 4 squared, I get 4 plus 16, which is 20. Okay, so that line, let's call it xb, so the line xb actually equals root 20. I'm just going to leave it as that just now. So xb is root 20. We now know that xa is 3, because that's from the question. So to do my red triangle, what we are going to be doing is root 20 squared, which is just 20, guys, plus 3 squared. Okay, so I'm going to have 29. So AB equals the square root of 29, which I'll get a calculator for that one, which is 5.385 blah 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 blah, so 5.39, and there's no units. Okay, so that's where we're at just now. Okay, so the length of AB is that. Can everyone see how that's happened? Can anyone spot a quicker way to do that? So maybe you can apply the knowledge that you've looked at already when we've worked out the magnitude of vectors, because that was just Pythagoras, wasn't it? So what we could actually do is the short way, the short version of that, which is the one that I actually prefer to use, is to do that sum and that sum together along with their square root. So AB actually equals the square root of 2 squared plus 4 squared plus 3 squared. Okay, and if you don't believe me, you can put it into the calculator and have a little try. So 2 squared plus 4 squared plus 3 squared equals 29, which equals what we had before. Much easier. Okay, so that's the method I'm going to use just now, but if you want to do the two separate triangles, please feel free to do so. Okay, so we should do the same thing for this one. Find the diagonal length of the cuboid AG. So we have all the lengths of the cuboid, and I'll just do it in different colours so you can see what's happening. So AG is what we actually want to work out, which is that one there. Okay, which means that I need to know this length, which I do, but I also need to know this length, which I don't, but I can work that out by using this one and that one. Okay, so we're doing Pythagoras twice effectively, but we can combine that to do AG equals the square root of 8 squared plus 6 squared, which is our bottom triangle, plus 7 squared. Okay, so you can put that into your calculator. 8 squared plus 6 squared plus 7 squared. Okay, which equals root 149. Square root in your answer, you get 12.2065, blah blah blah. Doesn't say anything about rounding, so round it to something sensible. 12.2 and then units, centimetres. Okay, this one here, calculate the length of FH and BH. So because this one's actually specifying for us to work out FH, first of all we have to do that. So FH, which is this one here, we're going to work out by doing this triangle. So FH is going to be the square root of 10 squared plus 4 squared, which is root 116. I'm just going to leave it as that. So therefore, us to work out what BH is, which is this one here, okay, we need to know that one as well. And there's our triangle. So BH, I'm going to just do it my quick method as usual because I just think it's neater. So it's the square root of all of them squared and added together. So 10 squared plus 4 squared plus 8 squared. Okay, so 10 squared plus 4 squared plus 8 squared is 180. Find the square root of that. 6 root 5, which is 13.4164, blah 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 blah. No specification about rounding, so you can round it to something sensible. 13.4 centimetres. Always remember your units. Okay, a little bit of a trickier one. A square base pyramid has a base with side lengths 5 centimetres and a sloping side of 13 centimetres. It has a vertex O and a midpoint of the base is at M vertically below O. Calculate the height of the pyramid. So a little bit trickier this time just because it's a different shape, but it's the same principle that we have to apply. Okay, so we want to find the height this time. Okay, so it's a shorter side that we are finding, so we can't just do it in a oneer this time. Okay, so it's a shorter side that we're finding. So short side we subtract in Pythagoras, but for me to know that, I need to know what this bit here is. And for me to work that out, I need to look at this triangle here. Okay, so that black triangle that I've just drawn, well, it's half the base, so it's going to be 2.5, and because it's square, that one's going to be 2.5 also, and that'll give me what that one there is. So x squared equals 2.5 squared plus 2.5 squared. So x equals the square root of, and I'm just going to leave it as a root. So 2.5 squared plus 2.5 squared is 12.5. Okay. So to find out our height, which they're calling OM, so OM, I'll do it in a different colour so you can see it. So OM is this bit here, that's what we're interested in. It's a shorter side of a triangle, therefore we need to subtract, short side we subtract. So OM equals the square root of 13 squared minus, now we've just worked out the x is the square root of 12.5, so squaring that is going to be 12.5. So 13 squared minus 12.5 equals, and then square root, 12.509996. No information about rounding, so we can round it to something sensible, 12.5, and then units, centimetres. So the height is 12.5 centimetres. Okay, copy today's examples and notes, complete today's exercise which you'll find on Teams, and please ask for help if you need it. Now if you have a little look there at the plenary question, this question had a bit of controversy, I suppose, when it came out on the SQA and that exam day. Lots of people were having a bit of a moan about it, so see if you can do it and let us know how you get on. Thanks for listening.